Hello guys, in this video I'm going to show you how to solve no repeating substring problem. So given a string, find the length of the longest substring which has no repeating characters. For example, with this given input A, B, C, B, we expect to have the longest substring which has no repeating characters is 3. Why is that? Because as you can see, here A, B, C, and if we substring, first substring means contiguous string, right? So ABC, if we add one more character to this substring, it would be either to the left or to the right. It will violate the constraint, which has no repeating characters. If you go to the left, it will be AA, BCC. If you go to the right, it will be ABCC, right? So, and of course, there are no others substring that is longer than ABC. For example, CB here could be a substring, but its length is only 2, right? Or any single characters is also a substring outside 1, which has no repeating characters also. So for these kind of problem, we probably want to check different possibilities, right? Somehow check all the possibilities, and one way to do that is use a sliding window, right? And one sliding window will covers one substring, right? So the idea here is to just for each window wanna count the number of non-repeating characters in that window, and wanna compare with the current longest substrings. If it is better, wanna update the current longest substring, right? And also we must have a way to slide windows, to slide a window to check other possibility as well. So let's run it manually here. A, B, C, B, B. Okay, lab will be here. The window is just combinations of left pointer and right pointer. We have left and right pointer here. So they both point to A now. So the current window will be we must have a way to keep track of characters and its frequency is count. For example, here A is 1, right? For the current window, we have one character A with its frequency is 1. Okay, so let's say initially the longest would be 0. So when I compare, when I check, is the current window produces a substring that is longer than the longest, which is 0 now. So yes, it is. So I will update the longest substring to 1. Okay. So again, we're asking questions. We ask the questions. Can we find because the current window is it satisfies the requirements. So we ask questions: can we find a substring that is better than, that produces better better size, better length than the current one? In order to do so, we're gonna expand the window to the right, which is now it's AA, and it is A with frequency 2. So it violates non-repeating characters attributes. So of course it will not consider a valid substring. So we don't consider update the longest here. So because it is now a invalid window, so we must make it valid again by moving the left pointer, right, to shrink it down to the point that it becomes valid again. So here, move the left pointer to the right one step. Now a window is A only, with one A is removed. So current window will be A with frequency 1. Here it is a valid substring because it has no repeating character. So I will consider the longest, but the size of the window is 1 is no better than the longest, current longest. So I will not update it. So again, you ask questions: can we find better substring by moving the right pointer, expanding a window by moving the right pointer rightward. So now it's AB with A of frequency 1 and B of frequency 1. Okay, so it is a valid substring because all the character has frequency of 1. So I will update the longest 2, right? Okay, again we ask questions: can we find better substring, right? Moving the right pointer rightward. So now it's A, B, C. C frequency 1. It is definitely better than, it is the first valid substring, and its size is greater than the longest, current longest, which is 2. I will update with 3. Okay. Continue to ask questions. A, B, C. Can we find better one? Move the right pointer right up. So now C has frequency of 2, which violates the no repeating attribute. A, B, C, C. Okay, so it is not a valid substring. Will not consider the longest here, and so we must bring it back to valid state by shrinking the window down until the point it becomes valid. So A is removed. Okay, it's still not, because C is still 2 here. Again, B is removed. It is still not valid substring. C removed. So we remove one C from here. So now it becomes valid again, but it is no better than the longest. Size is 1. It's no better than 3 here. So can we find better one? Move the right pointer right. We have C, B. B is frequency is 1. Here is a valid substring, but it is no better than the longest, which is 3. So we not update longest. Again, can you find better substrings? Expand the window by moving the right pointer rightward. Its size now B has frequency of 2. We have one repeating character here. So we'll not consider the update, but when I shrink the window down until it becomes valid again. And 1B for me. Okay, it becomes valid again. Can we find better window than this? Move the right pointer rightward, but now it out of range of the array, so we exit our processing. Okay, so let's try to turn this logic into code, right? What I use sliding window technique, right? For this problem, we window start is 0, and when iterate, when I start looping here, use for loop with window n. Window n, the valid range of window n will be from 0 to the size of string -1, right? Window n plus plus. So at the beginning of this this loop, right, we are considering expanding a window. We also need to keep track of the current characters in the window. So I'm using map. Let's call it frequency because it maps one character with its frequency. This will be a object, simply a map in JavaScript, right? So at the beginning of these iterations, we're considering adding, considering expanding a window, right? So the last one on the right will be current character will be string at window end. Wanna add this character to a window, which is to the frequency map. So add current character to frequency map, right? So that we must check if it is in the map or not. If it is not in the map, current char is not in the frequency map, wanna initialize it, value it with 0. Otherwise, no, not otherwise, but after this step, wanna increment it with 1. So if it's not in the map, initialize with 0, then increment its frequency by 1. If it is in the map, we skip this step and just increment its frequency by 1. So by adding one element, one character to a map, could it could make our window invalid. Okay, so assuming that here we are expanding window when previously our window is in valid state. By adding one character to a map, it could make a window invalid. So we need to add with this, as I described earlier, we need to bring the window to valid state. We'll do it by another loop. So as long as it's still is invalid, is repeating, for example, as long as still repeating, let's say has repeating characters, what we need to here is one way to check if the current window is invalid state is to use just to compare the number of keys in the map with the size of current window, right? So the map would be frequency. The current size window could be calculated from window start and window end. Let's implement it right away here. We have a map, we have start, and we have end. So the size, here the window size will be n minus start plus 1, and number of different characters in the map would be number of keys, right? Object of keys of map. We get a size So it has repeating characters when the sign is different than the keys. Okay. To be more explicit, window sign, and here would be non-repeating characters. Let's say different characters. Number of different characters. Okay. So if it has one character here, we will first take the first character to the left out of the map. So we take the first character. We get the first character first, which is the character at index Windows start. Okay. So wanna update its frequency in the map by decrementing with 1. Decrement by 1. So frequency first character, you get frequency decrement by 1. So if it reaches 0, frequency of first character is 0, we're gonna delete it from our map. We don't want to have a character of frequency 0 here. So after this step, updating the map, here we can increment the pointer rightward to shrink down the window until the valid point. Right, we shrink down the window. We come back here, check if it has repeating characters. If yes, again do this step to update the window. And if we exit here, it means it has no repeating characters now. Now we can consider to update the longest. Initially 0. The longest, we will update the longest substrings by using map.max, whichever is greater will be updated to the longest. We compare the longest with current number of different characters in our map. So our map at this point has no repeating characters. We just count the key. Right? It is a number of different characters. So after update here, we will come back to here. We come back to start of the for loop and again start expanding the window to the right, until a point out of range. We will exit the loop. We'll return the longest. Okay, I run the test. Just one. Whoops. Sick. So works perfect. So let's double check it one more time. Great. So that is it for this video. No repeating substring using sliding window technique. Thanks for watching. See you in the next video.